These are the practice problems for lesson 13. In this first problem, you're supposed to identify the image A, B, C, or D that is congruent with the image at the top. And so what I did is in Docere, I made a copy of that image, and then I just moved it over A, B, C, and D. So one way to tell if something's congruent is to take it through a transformation or a series of transformations. If it maps to that figure exactly, then it is congruent. And so it does not map to A. If you notice that the blue dots in the image for A are spread out a little bit farther than they are for the original image. Actually, B is the congruent image. If you rotate it and slide it right over here, everything matches. The angles match, the lengths of the sides match, and the dots in the middle match. And this is an activity that is further to give you some experience to understand that every part of an image that's congruent to another image, they're all congruent, they're all equal, they're all the same. So the lengths of the sides, the angles, anything within the images, everything has to be equal for congruent images. C is not congruent. It's slightly skewed, it's slightly off, this angle is a little bit different, and these dots up at the top have moved over a little bit. So it's as if they've twisted everything just a little bit, so it's a little bit off. It's not congruent. And D, it's rotated in the wrong way. So they've taken the dots and rotated them so they align with the wider angles across the middle here. Whereas in the original image, the dots are aligned with the smaller angles this way. So D is not congruent because the dots within D are rotated. So the answer once again is B. All right, for this problem, what you're supposed to do, they give you these two images are congruent. They tell you that in the problem. And they ask, well, if that's true, is angle ABC congruent to A prime, B prime, and C prime? In other words, do they have the same measure? Well, they have to. They are congruent images. They are corresponding angles. They have to be congruent. But first of all, this is just to show you that it is a 180-degree rotation. So if you connect the corresponding points, so A to A prime, B to B prime, and C to C prime, those lines all intersect at the center of rotation. That tells you that it is a 180-degree rotation. If you look further, you'll see that this side is parallel to this side over here is parallel to its corresponding side over here. So everything makes sense. It's a 180-degree rotation, which means that this angle has also rotated 180 degrees. So I just took it in Docere and rotated it 180 degrees, and you'll see that this side right here of the angle is parallel to this side. So when you rotate images, the sides are parallel in the transformed image. So this side BC is parallel to this side B prime, C prime. Well, actually, okay, that's okay to say it that way. So BC or B prime, C prime. And then I just slid it over the angle, and it shows that they are congruent. So you can measure them with a protractor in your student workbook or import a protractor into Docere and measure them that way and prove to yourself that they have an equal measure. They have to, because they are congruent angles. So corresponding parts on congruent figures are equal, always. That's what makes them congruent. All right, so a question might be, well, what is the size of this angle? If you're not going to measure it with the protractor, can we get an idea of what size it is? And so in Docere, I drew this right angle. So I took one line and crossed a 90-degree angle with another line and copied it and pasted it into this figure and rotated it and slid it up to this point right here. And so it overlaps with this line. So this is a 90-degree angle from this side over to this side right here. So that's 90 degrees. And so if you go past it, so I slid a square up here, and the diagonal of a square is 45 degrees. So if you measure from this side here all the way around to this diagonal of the square, that is 90 degrees plus 45 degrees. That's equal to 135 degrees. So it's 135 degrees to from this side of the angle to this diagonal. So the angle actually has to be less than 135 degrees, but greater than 90 degrees. And it looks like it's about halfway. Well, this is 45 degrees. Half of 45 is 22.5. So call it 40 and call half 20. So what's 90 plus 20? 110. So I'm just going to say the size of that angle is 110 degrees. And if you measure it, it's going to be very close to 110 degrees. All right, the next problem. They're asking you, are these two ovals, and actually this one looks like a circle, are they congruent? Well, if you draw a rectangle around them, around this oval on the left, and look at the length, how long it is compared to the width, or height, how tall it is, and you move it over here, you'll find out that those measurements differ for the circle. The circle is not as long this way, but it's wider or higher this way. So these two images are not congruent. So they tell you that these two images are congruent. And so what's a transformation that can take image A to image B? First of all, they are not rotations. I thought at first maybe they were. I took this image and I just kind of rotated it around to see what would happen if you do that. So I rotated this around and I slid it down to line it up. And you find that this angle is pointing in the opposite, or in a different direction. So this angle is pointing down, whereas this angle in the original one is pointing up. So it's not a rotation. It actually is a reflection. So this is the line of reflection. And so remember, for a reflection, you have to measure the distance from each point to the line of reflection, the perpendicular distance. So it's at a right angle. And then you place the point on the other side an equal distant from the line of reflection. So I move each of those arrows over to the other side, and they all line up with the points on this image on the other side. So image B is a reflection of image A. So once again, the corresponding point is an equal distance from the line of reflection on the opposite side, and it's moving in a perpendicular direction, or at a right angle to the line of reflection. So that is a reflection. Once again, line of reflection, it's right angle, and it's an equal distance, right angle, 90 degrees. Another word that we're using is perpendicular. So it moves in a perpendicular direction, or at a right angle, or 90 degrees. This image, this is a rotation. And it's actually a 90-degree rotation. So what I did is I took these squares and I placed them on the figure. The red square is placed on the side that's actually on the outside in the figure on the left, but then when it rotates, it ends up being on the inside in the figure on the right. So this square, this corner, is 90 degrees, and so it does match that 90-degree angle. The same thing with this pink square. I placed it at this vertex, but along the side that's on the inside, but then after the rotation, that same side ends up on the outside over here. And so that is, once again, a 90-degree rotation. So it's the center of rotation is right here. It's a 90-degree rotation. And to check the center of rotation, you can connect the corresponding points, find the midpoint, and then draw a line that's perpendicular to the line that connects the corresponding points. It will intersect with the center of rotation. Same thing with this point to this point here. It intersects. So find the midpoint, draw a line that's perpendicular from that line, and it will intersect with the center of rotation. So it just confirms that this is in fact the center of rotation. And you can see that by the way the figure is set up. I wanted to insert this short piece into this video because I missed an easy way to tell that image B was a 90-degree rotation of image A. So what you can do is just figure that out by counting. So first of all, this is a 90-degree rotation. So let me put a square right at the center of rotation, because if you go from this side to this side, that is 90 degrees. If you go from here, go through 90 degrees, 45 degrees to here, keep going, that's a 90-degree rotation. So we're going to use that in just a moment. So first of all, if you count along the x-axis to get to this first point here, it's 3 units along the x-axis and it's 1 unit along the y-axis. So it's 3 units to the left and 1 unit up. And the next point, this point over here, is 4 units to the left and 2 units up. So now if you just take these two sets of arrows and rotate them 90 degrees, so go up here and so go have them move up along this part of the square, you're going to see that it's the same count to get to the corresponding points in the rotated image. So count up 3 and over 1, count up 4 and over 2. So once again, this one is 3, 1. Its corresponding point is 3, 1. And the second point is 4, 2. And its corresponding point is 4, 2. So an easy way to see that it is a image B is a 90-degree rotation of image A around this point right here, which is the center of rotation. This problem is a translation. So you just take figure A and you translate it over to figure B. And another way to look at it is to move each point up 1 unit and to the right 3 units. So it's along the y-axis 1 unit and it's along the x-axis 3 units. Every single point, every single part of image A will move in that same manner. Up 1 unit to the right 3 units. And so remember, you get a prism. If you have two congruent sides, one copy is a translation of another side, or another, not side, but base. So a prism is a translated copy of a base, and they are then connected by parallelograms. So they connect each side to its corresponding side, and you get a face that's a parallelogram. If it's a right prism, you get a face that is a rectangle. And that's it. These are practice problems for lesson 13.